Hello and welcome to Tribetopper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos.
In this video session, you are going to learn about the absorption spectra. To understand the absorption spectra, we will talk about the absorption spectrum of hydrogen. Now, we have already learned about the energy levels and the transition that happens between the energy levels. So, if an electron, let's say in hydrogen atom, if an electron has to jump from the level n is equal to 1 to the level n is equal to 2, then it has to absorb an energy equal to this energy gap that exists between the two levels, right? So, it has to absorb a right amount of energy. You cannot say that it can absorb any amount of energy and then okay, it will jump and reach here. No, it can't exist anywhere in the space between level 1 and level 2. It needs the right amount of energy to jump to the level 2, level 1 and level 2. The electron absorbs the right amount of energy and hence a relevant or corresponding photon. So when it absorbs that corresponding photon, how does it absorb? So let's say that, so we can say that white light is passed through hydrogen gas. Okay, so white light is passed through hydrogen gas. Now what happens? See, the gas has its electrons in the ground state. Before you passed the white light, your hydrogen gas had all the electrons in the ground state. But moment this white light passes through the hydrogen gas, what's going to happen? All the some of the electrons, they are going to jump by absorbing certain photons from this white light, because white light is consisting of different wavelengths. It is polychromatic, so there might be certain wavelengths which may fill up this gap, because when a photon of a particular frequency or wavelength, which will give an energy equal to hc by lambda, which will be equivalent to the gap between the level 2 and level 1, and that gap is equal to go from minus 13.6 to go to 3.4 electron volt, it is going to need a 10.19 electron volt energy, which when converted into joules will give me a suitable wavelength. So therefore, wavelength which corresponds to this 10.19 electron volt of energy, that wavelength will be absorbed by the electrons. Now when that wavelength is absorbed, so that point you will receive a dark line, like you can see one here. Similarly, whichever number of electrons go on absorbing the energy. Now might be if there are some electrons, then electron present in the second state, when they have to jump to the level 3, then they need to cover up a gap of 1.89 electron volt. So when they cover up a gap of 1.89 electron volt to go from n is equal to 2 to n is equal to 3, that will correspond to some other wavelength, right? So that will be absorbed. Again, you are going to get a dark line there. So this means that when white light will be passed through the hydrogen gas, you will have some photons which are absorbed, means they will be found missing. So from the white light which was giving you a colorful pattern, you will find some dark lines. So just understand that these dark lines correspond to the missing photon. So the dark lines, they correspond to the corresponding missing photon wavelengths, right? So you get the absorption spectrum. So absorption spectrum of hydrogen would look like this. So emission spectrum was produced when the electrons were jumping from the higher levels to the lower levels by emitting certain wavelengths. So that looked where you had everything dark and you had the colorful lines. So the colorful lines were corresponding to the wavelengths of the emitted photons. Whereas in the absorption spectrum, it's just the reverse. The electrons are absorbing the photons of certain wavelengths, which give them the right amount of energy equal to sufficient to jump the electron from the lower to the higher level. So then those photons being absorbed are found missing in the white light, and then the corresponding wavelengths are missing, so you get the dark line. So this is how the absorption spectrum is formed, and this is how the absorption spectrum of hydrogen looks like.